Hello, and welcome to Still Behind the Bench. My name is Adam, and on this channel I will attempt to describe the science behind distilling spirits in a more technical way. You can think of it as an introductory college level course. Hopefully it'll whet your appetite to learn more and teach you enough so that you are more self-sufficient. So in this video, I'm going to go through materials used to make the still, collect distillate, and store final products and other cuts. So let's get started. Lots of materials are used in the construction of distilling equipment. In this video, I'm going to talk about stainless steel, aluminum, brass, and glass. You may wonder why I didn't mention copper. Well, that's because I'm going to be doing a separate video on copper. It'll probably be the video that comes right after the safety series. So, stainless steel. Not a whole lot needs to be stated about it. It's non-reactive for our purposes. It's non-toxic. It's very easy to clean. Easy. Can't write today. Very easy to clean. In my opinion, this is what most stills should be made out of. Most stainless steel used will be 304 or 316. And just like most other food safe vessels used in industrial or commercial industries, they use stainless steel. Now, a lot of people will say you should use copper because 1, tradition, and 2, copper can help remove some sulfur compounds, and that is true. But I think all these points, and a fourth or a fifth one, very strong, are the best reasons why you should use stainless steel as your boiler. And if your wash is particularly sulfury, you can actually just throw copper into your boiler and it'll react as if your boiler was made out of copper itself. The next metal I'm going to look at is aluminum. It is very different from stainless steel. It's a soft metal. It can be toxic to humans. There is a study titled Occurrence, Exposure, Effects, Recommended Intake, and Possible Dietary Use of Selected Trace Compounds. And they talk about aluminium. It's the first metal that they talk about. And I've read it, and using the least harm principle. Oh, and this will be in the description, the DOI number. Using the least harm principle, the minimum risk level amount considered by the European Union, since they have the lowest amount, is 1 to 2 milligrams per kilogram per day. So for me at 90 kilograms, that would be 90 milligrams to 180 milligrams. That is both a lot and not a lot at the same time. So in my opinion, aluminum should only be used as the boiling vessel because you don't want any of this aluminum coming past the point of no return, which is essentially right there. So use it as the boiler. Don't use it as the column. Don't use it as your condenser, because it will pit. It's going to happen because the wash is acidic. And using it only as the boiler, all the metal will stay in the boiler. It's not gonna travel up and come out your condenser if it's just the boiler. And it's an alright metal to use as the boiler too, because it transfers heat a lot better than stainless steel does, but not as good as copper. The next metal is going to be, our next material is going to be brass. Now, the problems with brass are that it can have issues with lead and zinc. Now, any fitting that's going to be used for potable water is not going to have lead in it. At least if it was made in the last 30 years. Your only problem is going to be zinc. Now, you can find zinc fittings with the following designations. Brass fittings with these designations will not leach out zinc. DZR means dezinkification. Man, I can't write today. Resistant. So these both mean that. And then CR just means corrosion resistant. It's the same thing, they just give it a different name. I would not buy any brass fittings that didn't have this designation. You don't want zinc poisoning. Realistically though, all your plumbing fittings, or all your fittings are going to be plumbing based, and most likely they're going to be outside the pathway of the vapor or the condensate when it becomes your distillate. Like I use these two fittings, they're on the condenser, and they just let me connect tubes to pipe the coolant through the condenser. These never come into contact with the actual vapor or condensate. So yes, make sure you have one of these designations when you're going to be buying a brass piece. The last material is going to be glass. It can be a great material to use in your still. It has a lower thermal transfer coefficient than metals, so it holds in heat better. Your column will, depending on how you're using the glass, your column can stabilize a lot quicker. Well, maybe not a lot quicker. It can stabilize quicker, not by a huge amount though. Most importantly, it lets you see what's going on inside. There's essentially two ways you can use glass. You have what's called a sight glass. That lets you peer inside, and there'll be like a little piece of glass in this part here. And this will be open. Like this, so you'll be able to see inside, maybe at a plate, maybe packing. You'll see the vapors. Well, you won't see the vapors, but you'll see them condensing on surfaces. You'll see your plate bubbling. You'll see the packing dripping. It's a great thing to have. My column has a different kind of glass in it. I mean, I do have one sight glass at the very top for my reflux condenser, since I use a CCVM type still. And we'll get into still designs a bit later. But mine is actually main column, which you can see in the picture in the thumbnail. Glass pieces, glass cylinders, I should say, with platinum cured silicon gaskets, the top and bottom. And then, you know, I can pack it with copper, or I use a plate sometimes. And it's just a really neat way to do it. You can see whether or not your packing is flooding, or if you need to increase reflux. It helps you diagnose what's going on inside a lot easier than having just a straight metal tube which you can't see inside. Another glass thing that people will put on their stills is a glass thumper, and they'll use a mason jar, typically a wide mouth, but you know, they have your two pipes going in. Draw a quick little diagram here. I am not that great. That's a bad. That's better. It's calling Da Vinci. All right, so we have our thumper tubes input and output. I need the liquid in here. So a lot of people, maybe not a lot of people, but enough people will use the mason jar, and they'll seal off the tubes at the top here. And since the top of their column is really high up, so you know, this will, or however they have it. They'll leave this up in the air hanging. That's a very bad idea. The threads here are not load bearing. Why can't I spell? Boom, not load bearing. So you can run the risk of it dropping down. Mason jars are typically just made of regular soda lime glass, so they don't have good thermal shock capabilities. So you can't swing the temperature very wide. It's not gonna swing very wide in the first place, but there can be a problem if you're doing it outside and it's hot and there's a big gust of cold air that comes through. So what I suggest is you put it inside a little Tupperware container. So if it breaks open or it decides it's going to drop, this can catch it. And that can sit on top of a simple stool, right? That way it won't fall. Doesn't require, this lid isn't load bearing. There's no strain on it. If it does, glass cracks open, all this liquid, if it's heads or tails, or just water, I guess, but if it's heads or tails, it'll just fall into this container you have it sitting in. You won't be stepping on broken glass, and your flammability risk will drop quite a bit. So yeah, don't put your thumpers up in the air. Don't put your mason jar based thumpers up in the air. Although realistically, I just make it out of copper or stainless steel. It's a lot easier. Then you can use it load bearing. All right. Now on to solders. You want your solder, obviously, to be 100% lead free. Obviously, don't cheap out on it. Don't buy old plumbing solder. Just get the lead free stuff. You'll also need to pick up a lead free solder flux. Flux doesn't actually have metal in it. The lead free just means that it's formulated to use with a lead free solder. There are a whole bunch of different solder alloys out there. I would recommend tin silver. It's 3 to 5% silver, the rest is tin. You can also get tin silver copper. Both of these are great alloys. They take more heat to melt than lead-based solder. Not a huge amount, but it's noticeable. But they're still great to work with. They still flow great. There are also some alloys out there that have antimony in them. Do not use those. Antimony can oxidize into a compound called antimony trioxide. It is very poisonous. It is arsenic level poisonous. It's unlikely that it would ever form in your solder joints, but why risk it in the first place? I say no to antimony for your solder. Just choose one of these two. Most hardware stores will sell them these days to be RoHS compliant, and they sell them on Amazon as well. So let's get into some collection vessels. So for a collection vessel, it might be enticing to use just any old container to collect your distillate. I say don't do that. Both the heads and the tails compounds have chemicals in them that can break down plastics, dissolve. You may not actually see it. It might only be happening on the surface, but it is happening. And if you're just collecting your stripping run, once they're in the wash for your spirit run, these dissolved compounds can follow the hearts out and get into your final product. Use glass or stainless for collection. Mason jars are perfect for this. You can buy the cartons of these really cheap. They come in 12 and 24 packs. I use these 1,000 milliliter mason jars, and I also use 500 milliliter mason jars. I use the 500 milliliters when I'm beginning, and I collect up to about 250 milliliters in each one. And then once I know I'm fully into the hearts fraction, I will switch to the 1,000 milliliter mason jars. And then once I'm switching back to the tails fraction, or once I believe I'm going to be getting into the tails fraction soon, I'll switch back to the 500 milliliter jars. For storage, things are a bit different. For your heads and tails, use only metal or glass. I'd say preferably metal, because if you drop it, it doesn't smash open. You don't have to buy a special chemical disposal container, but I would use a metal container nonetheless. Because the heads and tails that are going in here are going to be particularly flammable. more so than ethanol most of the time. For your final product though, you can use plastic, glass, or metal. You've probably seen plastic bottles like this. This is a Pepsi bottle. It's made out of a plastic called PET, or polyethylene terephthalate. You've probably also seen plastic bottles full at the liquor store with varying levels of varying ABVs of spirits in them. They're all made out of the same plastic, PET. It can handle all concentrations of ethanol and won't leach anything. It can also handle low concentrations of a whole lot of other organic chemicals. Technically, you could use PTFE or Teflon as a storage bottle, but they're super expensive, and I doubt anybody's going to be buying that. Personally, I use glass bottles, old wine bottles, old spirit bottles. You can use new corks to seal them up, or if you still have a cap, you can use that. You can use mason jars, but I would recommend getting, I don't have any spare ones, but you can get what's called a PTFE, Teflon cap liner. Essentially, it's the same diameter of this, and it's probably the same thinner than that. And you put it on top of your mason jar, and you put on this lid, and you put on the threaded part. You can get them in a bunch of different places. Get them from US Plastics, which is where I buy mine from. Well, most of the time. Or Thomas Scientific. I've also bought from them before. The two sizes I use, and you'll probably want to measure the diameter of your jars, but 63 millimeter or 2.48 inches for regular sized, and then 89 millimeters or 3.5 inches for wide mouth. These seem to be the correct sizes for me. They fit all my jars. And I'm not worried about vapors or leaving a jar on its side or even upside down with one of these liners in there. I hope this video wasn't too complicated. If you liked the video, please click the like button. If you want to see more, please click the subscribe and click that bell for notification of new videos. If you want me to do a video on a specific topic, leave a comment or send an email, and we can discuss it. Thanks for watching. Have a great week.